Hey everyone, sorry I'm not here, but I'm going to dive right into your favorite topic. Please do this on graph paper, and please know that I'm not going to take any homework that's not on graph paper if it asks you to graph. Don't be lazy, just make it happen. Okay, to start, I'm going to sketch this out because the tool doesn't seem to be working well. We have the classic XY axis, and I don't really care if you guys label them X and Y, but you do need to know that this right here represents positive X, this right here represents negative X. If we go up, we have positive Y, go down, we have negative Y, and then we have the quadrants, quadrant 1, quadrant 2, quadrant 3, and quadrant 4, and finally we have the origin, which has the order pair of 0, 0. This represents 9 distinct regions of the coordinate axes, 9 different places they could be. So, I don't want to kind of go into the specifics of ordered pairs. You guys have been graphing ordered pairs since you were very, very tiny. But I do want to remind you guys a little bit on how to graph equations. So let's start with kind of a basic linear equation. Y is equal to 3/2 x. Now, what makes it linear is that this x is to the first power. So linear means first degree, which means no exponent more than 1. So both the y and the x here have an exponent that is just 1. Now, if I were to start graphing this, which I'd like to do, if this would let me do the graphing tool. Maybe if I switch away and switch back to it. Yeah, that worked. Okay, I got my workaround. If I did graph this, we've got a couple ways I can graph it. Method 1 is to t-chart. So if I t-chart it, I have x and 3/2 x. And I'm looking for ordered pairs, both positive and negative, that just get a pattern going. So if I put 0 down for x, that would be 0 for 3/2 x. 1 I could put down, but if I put down 1, I get 3/2 for x, which is equal to 1.5. If I put 2 in, I get 3. So even numbers are going to be a lot better because they're going to cancel with the denominator of the 3/2. So if I put 4 in, I get 6. Okay, that's enough there. Now let's go -2, which is going to be -3 and -4 and -6. So if I go over 1 and up 1.5, I can put that here, but really it's kind of better to do 2, 3, 4, 6. I know 0, 0 was a point, so let's put 0, 0 in. -2, -3 is left 2, down 3. And then -4, -6 is left 4, down 6. Now, you can kind of put these points in as well, what I would call the halfway points. If we're going up 3 over 2, I could go up 1.5 over 1 and put the points in and just draw them that are in between. If you do that, it doesn't become so necessary to use a straight edge so much as it is to make sure that your lines go through the exact points that they should. I'm going to use a straight edge here. I would recommend you guys have a straight edge just to make sure you do that. But again, it's far more important that you stick points at every possible place that the line would cross. Now, other examples, let me kind of go to a second method here to graph, one that might be a little bit more familiar with you. Let's put a grid down. So, nope, I don't like that. So we're going to write the equation first. Y is equal to 3/2 x minus 3. And I'm going to put a grid down. Let's do my little workaround, and there we go. Okay, 3/2 x minus 3. And we need to put ordered pairs that are actually solutions to the equation. We need to find ordered pairs that satisfy this equation. You'll kind of notice that, like before, if I t-chart it, I get I have to plug in values that are even into x because that's going to cancel with the denominator. So that's one way to kind of go about it. Method 2 is to use the slope. Oh, thanks, Nick. Slope and the y-intercept. Now, why the y-intercept? Because it's easy to find. I know that if I plug 0 in for x, I get -3 for y. I also know that that means that this number here is the y-intercept. The y-intercept is the point that crosses the y-axis. So if I put a point here, I know that that point is 0, -3. Then I'm also going to look at what the slope of the line is. The slope is the coefficient of the x term when it's in slope-intercept form, so that is -3 halves, or +3 halves, sorry. So slope, as you may remember, is a rise over a run, or a change in y over a change in x. So from that point, I would go up 3, right 2, put a point. Up 3, right 2, put a point. And I would get all the possible points, and then if I'm doing this by hand, I'm going to do what I did before and do the halfway points. Up 1.5 over 1, up 1.5 over 1. You can eyeball these and know kind of where they fall. And then finally, we're just going to connect the line with hopefully a straight edge. There we go. Nope, that was not it. Okay, so I have to do that trick too. Move away from it, move back to it. What's interesting to note from that perspective, comparing this line to the one right above it, is that this line is the same slope as the one right above it. So if I actually were to graph the one right above it on the same axes, so I'm actually going to pull the same graph. That graph started at 0, 0. And it went up, over, down, over. And I'm just going to kind of go quickly on this and connect these lines, or connect these points. You can see that these actually are parallel lines. This is y equals 3 halves x, and this is y is equal to 3 halves x. 3 halves x minus 3. So this line here is like this line, sorry, I'm trying to indicate which one I'm talking about. This one is sort of a downshift of the one right above it. It's like I took this blue line and I moved it down. And if I move it down, it's actually going to perfectly line up with the red line. That's because they are the same slope. They're parallel. They'll never cross. But this is going to move into another example. Let's do one where it's the same slope, y equals 3 halves x plus 4. And let's set up an axis. So, well, okay, we can go there. I'm just going to move it up here. So I set up an axis, and so once again, if I look at the y-intercept, I know that the y-intercept would be the point where I plug in 0 for x, and I get 4 for y. So I'm going to hopefully redo this, because that was a little small for what I need. So let's make that a little bit bigger. I'm going to put a point at 0, 4. I know that the slope m is 3 halves. So we go up 3 over 2, down 3, left 2, and I get the same thing. And as you can hopefully see, comparing up above with the ones that you've done, here, let me finish sketching this, and put the little half points in, and then now let's take the tool and draw it. This is also parallel to all of those, but this is an upshift. This was an upshift from y equals 3 halves x by 4 units. So in general, we call these things vertical translations. We're going to say if y equals mx is a line that passes through 0, 0, which is the origin. So it passes through 0, 0. And that would make sense. I mean, if I plug 0 in for x, I get 0 for y. Then we know that y equals mx plus k. And now k, I have to say, for k positive, if y equals mx plus k, shifts the line k units up. And y equals mx minus k shifts the line k units down. So knowing that, I could kind of continue this and say, well, if I were to compare graphs of, let's say, I want to do a new graph, and let's look what number I'm on. We're on number 4, so let's just do number 4. If I were to compare graphs of, let's say I have a red line, and I go, let's put this one down. So I'm not going to draw the points on this one, but this is the one that we saw before. This is y equals 3/2 x. And then let me do one in a different color. I need a little bit more space here. So I'm going to sketch this one, which is... you tricking me. Okay, sketch this one, which is y equals... yeah, I got that right. You guys get just right. Okay, so if the blue one is y equals 3/2 x, then, or sorry, the red one is y equals 3/2 x, then the blue one, if they are parallel, and you look at what the y-intercept's doing, this one's at 0, 0, but this one's at 0, -4. This is a downshift of 4. Every point below it is 4 units away. So this should be the same as y is equal to 3/2 x minus 4. Okay, next thing, we're going to kind of go back to t-charting. T-charting is a way to graph just about anything that you may want to graph. So let's say I want to graph something like y equals 2x squared. If I'm graphing y equals 2x squared. So you may remember from Algebra 2 that that's going to be a parabola, and it's going to open upwards, but you may not, and that's okay. You don't need to. What we do need to do is, before I kind of start graphing, we need to put some x, y values down. And we need to make sure that we get values where nothing changes. So if I put 0, 0, that works. If I put 1 for x, I would get 2 times 1 squared, that's 2 for y. But also if I put -1 for x, I get 2 for y. Then let's just put a few others. 2, so 2 squared is 4, and then that would give me 8. And -2 also gives me 8. And that's going to be about as much as I can do, because if I put 3 down, I get 18, and that's going to be off the graph. I mean, at least for what I can draw. So let me draw this before I pause and go to my period 1 and try to keep recording this. 0, 0, 1, 2, -1, 2. See, I'm already off the graph, but that's okay. I can get 2, 8 in there. We'll put it up here and put -2, 8 up here. And we're just going to do a sketch. And when I do a sketch, I always draw each side separately so that I can get, oh, sorry. That way I can get it looking somewhat smooth on the curve. Okay. I'm going to pause and resume in a sec. Okay, continuing. Let's say I want to graph y equals 2x squared minus 2. So I can use the graph we just did to graph that. I can say we have this same t-chart up above, x, y, but all of those y points, 0, 1, -1, 2, -2, all of those are going to get a -2 on them, because this -2, after I do the square, represents taking this graph up above and literally dragging it down 2 places. Hang on, it does not like me approaching the top of the screen. Okay, so if I drag it down to, no, I just wanted the graph. Let me see if I can do this, and if not, well, there we go. So if I drag it down 2 places, that's going to be y equals negative 2x minus 2. The ordered pairs would be all of those y ordered pairs, but minus 2. So negative 2, see I'm kind of subtracting 2, 0, 0, and then 6, 6. And I got that because this particular t-chart from above, it's the same t-chart, but every one of those y values, every one of these, I just subtracted 2 from because of the minus 2. So now if I go to graph this, and I don't want to graph and highlight, so if I go to graph this, the shifting of minus 2, I got 0, negative 2, 1, 0, negative 1, 0, 2, 6 is going to put me up here, negative 2, 6. I get a graph that looks like this. Okay, next one. Y equals the absolute value of x. So this graph is very similar to ones that you, or to lines. It is actually, and I'm going to put this definition down, even though you haven't seen this particular one in a while. This is the same as y equals x, but only when x is greater than or equal to 0. And it's y equals negative x, only when x is less than 0. That is a way of saying the absolute value without using the absolute value. Well, you don't need to memorize that, but you do need to know what this graph looks like. The graph of y equals the absolute value of x, if I start putting a t-chart down, x, absolute value of x, 0, 0, 1, 1, 2, 2, 3, 3, but then let's put negative 1, 1, negative 2, 2, and negative 3, 3. So if I graph these points, I put 0, 0, 1, 1, 2, 2, 3, 3, negative 1, 1, negative 2, 2, negative 3, 3. It starts to look like, I'm just going to draw this by hand, it looks like that. And then it looks like this as you go through all those 45-degree angle points. Okay, that's y equals absolute value of x. Y equals absolute value of x plus 2 is to take all of those ordered pairs and add 2. So let's do 0, 1, 2, 3, negative 1, negative 2, and negative 3. And I'm going to graph, let's see, let's call that y. And I'm going to add 2 to all the ones up above. So 2, 3, 4, 5. And then this would be 3, 4, 5. So if I graph this, nope, did not want to go there, sorry. You have to almost think like a computer. And in this case, it thinks the cursor is up there. So I have to draw here a little bit, then go here and, no, I thought that, okay. Just going to come back down here and draw, sorry. This is me frustrated and just moving back down and accepting I'm going to have to draw the axes. So let's draw the axes. Down, over, 0, 2, 1, 3, 2, 4, 3, 5, then negative 1, 3, sorry, negative 2, 4, negative 3, 5. I'm going to go outwards and outwards. Oops. Let's get that one to be 45 degrees. Okay. Next type. Let's talk about lines, and especially within concept of intercepts. So let's say that we have the graph of 2x minus 4y is equal to 8. A couple ways we can do that. We can put it in slope-intercept form and graph it like we did before. I can use method 3 for lines. This is another linear equation, which is x-intercepts and y-intercepts. X-intercept occurs when y is equal to 0, so I actually look up to that, and I make y be 0, so I go 2x is equal to 8, and x is equal to 4. And if I graph that, I get the ordered pair 4, 0. And then I'm going to graph the y-intercept, which occurs when x is equal to 0. So I go back up to this thing, I cover up that, then I just divide by the -4, and I get y is equal to, well, let's actually get -4y is equal to 8, or y is equal to -2. Which means that 0, -2 was a point, just like here 4, 0 was a point. So 0, -2 is that point. Then I look at those two and I see, okay, halfway between that is this. So then I'm going to do an up 1 over 2 on a lot of this. And then I'm going to connect the dots. And I have the line. Sorry, that was a very poor line. There we go. Okay, next one. Number 10. We're going to find the intercepts of y equals -2x squared plus 8 and graph. So the let's start with the y-intercept because that's easier. The y-intercept occurs when x is equal to 0. And when x is equal to 0, y is equal to 8. That one is fairly easy. So I can put 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. The x-intercept occurs when y is equal to 0. Get 0 is equal to -2x squared plus 8. If we subtract 8 from both sides, I get -8 is equal to -2x squared. Divide both sides by -2, and I get 4 is equal to x squared. And I have x is equal to not just 2, but plus or minus 2, which gives me two possible ordered pairs, plus or minus 2, 0. So I could go right 2 or left 2 and put a point. And really I'm just going to now connect those because I know that this is going to be a parabola shape since it's an x squared. Okay, last bit. As a review, if it's an x equals line, like x equals -4, that means that every single ordered pair has an x. So what I would do, if you're confused about the vertical horizontal line thing, what I would do is I would simply graph 2 points that have an x of -4. -4, 0, and -4, 1. If I go -4, 0, and -4, 1, that gives me 2 points, and basically every point on there should be in the same thing. So when you graph that, I should graph it in a different color. We get a vertical line. Vertical means up and down. Number 12, y equals 3. I would just do 2 ordered pairs that have the same y values. So let me put a grid down of, there we go. And if I put 2 ordered pairs, it could go 0, 3, and 1, 3. Those have the same y value. So 0, 3, 1, 3. I can see that that's horizontal. So we're going to connect every point the same way. Okay, that's it. Just get started on your homework. This is not due until after the test, but I would start on it now so you have fewer things to do, especially in this class. See you later.